reality. So first of all, monocamera means that we just use one camera. In our case, we use a tablet device. Multi-view means that we just don't use a single view for the in-painting task. We use multiple views. And diminished reality involves an almost real-time capability of our algorithm, as well as an active tracking algorithm for tracking the pose of the camera. So I just want to, at the beginning already, focus on the main contribution of this paper. So we apply a keyframe-based in-painting, which is the in-painting algorithm is similar to the one, but slightly different from the one proposed by Herling et al. Whereas we use a scene model for creating these multiple views. We can get this scene model because we have active tracking. In our case, we use PTAM, which allows us to receive a sparse point cloud, and then we basically segment this point cloud to get up to receive the scene model. Then, based on the scene model, we have keyframes based for each of the planes we found in this model. And then the last question is, okay, how can we define good keyframes, which are very important for good in-painting quality? So first of all, a short overview what are keyframes and what is diminished reality. So you see here this image with this green pole, and the keyframes are most important for temporal consistency. As you can see here on the left side in the video, you don't have keyframes. In this frame we in-paint each frame. So this is on the one side very computational complex, but on the other side there you see it's flickering, where on the right side we have just one keyframe. And because we know the plane, the table in this case, we just transform this in-painting to the current frame basically. So now we come to the scene model. As I said already, I use PTAM, which delivers us here this point. You can see, I hope, this blue points here in this image. And then we use just iterative Renzek. So in future work we maybe use more dense SLAM algorithms to get a better representation of the scene, to be, in this case, more precise. And when we have a successful, in this case, scene model, it looks like this, where we detected these three planes. And then we separate the image into, we segment the image, as you can see here, based on this plane information. And then you can in-paint each of the as you can see here on the right side, each of the three images separately. And in this case again, the green cubicle here is our target region, which we want to diminish. So we separate into the three images and separate each of them separately, as I said. And that's then the final result of the in-painting algorithm we implemented. And then we just transform it back to the pose we tracked, to the current camera pose we tracked, and stitch the images together. And as I said, we have keyframes for each of the planes. So these keyframes originate also from different points in time, which also includes different poses of the camera, as you can see on the left side. And which comes up then to the next question, what is a good keyframe? So we come up here with a very neat metric. We just said, okay, the view to the plane should be as frontal as possible. So as I wrote here, the smallest yaw angle to the plane is for our algorithm the best plane. And on the bottom here on the slide you see a bad example. For example, a bad example on the left side. This is the first keyframe when we start our video, and then we do the transformation. And then you see on the right side, because now we have a more frontal view to this plane, that the texture basically is stretched, and then the result looks a little bit blurry, as you can see here, I hope. So if you are more interested or have more questions, then just come and visit my poster. Here's a short demo. So you see at the beginning we have to get tracking, we have to get so basically a point cloud, and then we in-paint each of the three planes. The flickering here at the end is mainly because of tracking failures, so it's just PTAM, so it's not very precise. Okay, so thanks.